Hi, welcome to the Unit 5 Extra Credit video for Learning Target 5.1. It's important to note that this video will not be graded, although this is an Edpuzzle video and you'll be asked some CFUs. I will not be grading those CFUs. You'll be graded on the practice for this learning target. This video is designed to help you prepare for the graded practice or extra credit. To begin with, Learning Target 5.1 is I can balance equations, and there are two important skills that we need for that. First is reading and interpreting chemical equations. So when you look at a chemical equation, what does it mean? And the second is understand that equations have to be balanced by the law of conservation of mass. So you need to be able to do those two things in order to balance them. As far as the law of conservation of mass, we'll touch upon what that is, but we will not in this video address how to balance equations. There's a separate video for that, one that you did for homework couple of weeks ago, so you may need to refresh by doing that video or watching that video. I have linked that video in the extra credit assignment, so you can find it there as an optional video. Beginning with interpreting and balancing equations. So a question like this, which is what is the chemical equation for this reaction, is testing your ability to interpret what a balanced chemical equation means. Typically we write chemical equations the way that they're shown here in the answer choices below, because it's just easier and we don't have to draw them all out. But for each balanced chemical equation or any chemical equation, it means something. Notice that there are two types of numbers that we use. We use coefficients and we use subscripts. So coefficients are the big number in front and they tell you something, and the subscripts are the small numbers and they tell you something different. So if you look, for example, here, 203, the 2 is the coefficient in front, is the big number in front, and the subscript is that little 3 there. So a question like this is just testing your ability to interpret a chemical equation like the answer choices and understand that they tell you something about the number of molecules and the atoms the molecules are made of. Okay, so what we're going to do is we're basically going to translate this into chemical formulas and use coefficients to show how many molecules that they are. So we'll start on the reactant side. The reactant side is to the left of the arrow, and you notice that there are two different types of reactants. There's one that looks like this, and then there are some that look like this one over here. Okay, so how do we interpret that? If we look at this first molecule here, we notice that there's only one of them, only one of this type, and I know it's just a single molecule because notice that all of these atoms are all connected together, so they're not separated. So I know this is one type of molecule. For that one, we would use a coefficient of 1. But just like in math, if there's no, if the coefficient is 1, we don't write a number in there, but you just have to know it's 1. Now for this one type of molecule, there's 1, 2, 3 carbons, and there are 8 hydrogens if you count them up. So the chemical formula for this would be C3H8. So that's where the subscript comes in. They tell you how many atoms are in that molecule, and these atoms are all connected together, so this is one whole molecule. The coefficient of 1, again, we don't write it in, even though there's one molecule, but we won't write that coefficient in because it's 1, so we just know it's 1. For the next type of reactant, we see that there are 3 of them, 3 of this type, and so for that we use coefficient of 3. How do I know that there's 3? There's 1, 2, 3 things that are separated, and these 3 things look exactly the same. Okay, these 3 things that are separated look exactly the same. So there's 3 of this type. And for this type, there are 1, 2 oxygen atoms in that molecule. So we would use the subscript of 2 to show the 2 oxygen atoms. Perhaps at this point you're ready to try it for the product. So if you are, you can pause it now. If not, I'll reveal the answers in a moment. For the products, there are 2 types of products. Again, there's this grouping over here and then this over here. And notice for this very first type, there's 1, 2, 3 of them, because there's 3 separate things. So I use a coefficient of 3. And in each one, there's 1 carbon and 1, 2 oxygen atoms. So for the subscripts, I would have a 1 for the carbon. And just like for coefficients, if there's no subscript, if the subscript is 1, we leave it blank. So I know there's 1 carbon here and 2 oxygens. And for the last product, there's 1, 2, 3, 4 of this type, and for each of those, there's 1, 2 hydrogen atoms, so 4 H2. So in a problem like this, the best thing to do is sort of what we did here, which is write everything out underneath and then figure out which answer choice matches that. So going through the answer choices here, the one that matches at the best, or matches it exactly, is choice D. You notice everything matches up. We're going to do one more example, and then you're going to try a CFU. If you would like to try this example before we try it together, then you can pause the video, and when you press play, we'll go through the answers. All right, so starting on the reactant side again, I noticed that there are two different types of reactants. And let's begin with this very first type. Take a look at these aluminum atoms. Are they connected together? No. So are they in a molecule? No, they are two separate atoms. And so because they're two separate things, we use that coefficient of 2 there and show that there are two atoms. So this would be correctly written as 2Al, not as it is for choice A, which is Al2. That is wrong because this 2 would make it seem like they're connected together, and they're not. So we have to use a coefficient. Here for the next one, for the next type of reactant, we see 1, 2, 3, 4, 5, 6 of this type. So we would use a coefficient of 6. And for each of these types, we have 1 hydrogen and 1 chlorine, so HCl. Going on the product side, we have two types of products. So we have this type and we have that type. For this very first type, there are 2 of them. It looks exactly the same, right? These two things look exactly the same. And in each of those, we have 1 aluminum and 1, 2, 3 chlorines. So we would write AlCl3. For the last type, there are 1, 2, 3. Notice that those 3 things are separated, but they look exactly alike. We have 3 of these, and these are the H2s. There's 1, 2 hydrogen atoms in each. So once we have it all labeled out, we can identify which matches that, and that would be choice B. So just a quick recap, the coefficients will tell you how many molecules or atoms you have, but we only use coefficients for things that are separated, things that are exactly the same, but there's just separate groupings of those things. And the subscripts we use for a single molecule, you just focus on one of them. How many atoms do you have? That's what the subscript tell you for a single molecule. All right, now we're ready for our CFU. You're going to try the CFU. It's good to write down your work or do your work on a separate piece of paper, and then from that, choose the correct answer. After you've tried the CFU, the answer will be revealed to you. Okay, so here is the answer. Just take a look at the work that's done. All right, if you have any questions about this, what I would do is go back to the beginning of the video, see if you can understand what your mistake is. And if you have any questions, you can always shoot me an email. All right. Before we move on to the next part, what's a good idea is to sort of summarize what you've learned in this section of the video and in terms of interpreting chemical equations. So key things: what do we use the coefficients for? What do we use the subscript for? And how would you, just in general, like what are the steps that you use to interpret the chemical equation written out with these sort of atomic and molecular models? These are models of atoms and molecules. How do you take that and write it into the chemical formulas shown below? Okay. The next part of this video is on law of conservation of mass. So we use this law to justify why we balance equations the way that we do. The law of conservation of mass states matter cannot be created or destroyed. That means the amount that you start off with should be the amount that you end up with. So let's say, for example, you start off with 10 grams of reactants, you should have 10 grams of product. On the flip side, if you make 35 grams of products, how many grams of reactants did you start off with? Should be the same number, 35. So these two masses should be equal. The other thing is, since we are not creating or destroying matter, and atoms are matter, then the number of atoms on the reactants and product side need to be the same. Meaning that if on your reactant side you have 12 carbon atoms, you should have 12 on the product side. And that's the basis for balancing equations. So let's take a look at the first understanding of law of conservation of mass, that the mass of reactants and products must be the same. If you're given a problem like this where you're asked to fill in the missing information, and you'll notice you have in this table here reactants and products, and they give you the masses for those things. But one of them, O2, which is one of our reactants, we need to find the mass for. Well, how do we do that? What we need to know is that the mass of the products must equal the mass of the reactants. So here we only have one product, and its mass is 10 grams. So for our product side, we have a total mass of 10 grams. That means that for the reactants, we should have a total mass of 10 grams as well, right? Because these two numbers have to equal. So if the mass of reactants must be 10 grams, when we take a look here, we know that, well, 3 plus what will give me 10 grams, and that will help us to find the mass of the O2. So if we do some mental math, we know that the mass of O2 must be 7 because 3 plus 7 will give us a total of 10 grams. And once again, the mass of reactants and products must be equal. Let's try again for this problem. So if you want to try it on your own first, you can do so. You can pause the video now. If not, when you press play, we'll go through this together. In this case, we're missing the mass of one of our products. So let's figure out what's the total mass of reactants. We have 64 grams of calcium and 192 grams of zinc carbonate. When you add those together, you get 256 grams of reactant. That means that the total mass of the product must be 256 grams. And so what we're going to figure out, well, we know that the calcium carbonate is 152. Well, what must be the mass of zinc? You could do some mental math or subtract both sides by 152 to isolate your unknown. And in either case, you find that the mass of zinc has to be 104 grams. And so that would be the answer there. All right, now you're ready to try a CFU. So for this CFU, you are going to do your work on a separate piece of paper. And when you are ready, you can hit, after you've entered your answer, you hit play again, and the answer will be revealed to you. Okay, so the mass in this case of H2, our unknown, is 10 grams. At this point, you want to sort of summarize what you've learned about the law of conservation of mass, and how would you use the law of conservation of mass to find the mass of reactants or products that are missing. Okay, now we're going to go into the last part of the law of conservation of mass, which is balancing equations. This video will not show you how to balance equation, but it will just help you to recognize if an equation is balanced and to perform answer a simple CFU. So in order for an equation to balance, the number of atoms on the reactants and product side must be equal. And the way that we balance things is we balance by changing coefficients, not subscripts. So remember, coefficients are the big number in front, and subscripts are the small numbers. The reason why we can't change the subscripts, because if you change the subscript, you actually change the molecule. We don't want to do that. We just want to change the number of a certain type of molecule we have in order so that the atoms are balanced. The next thing to remember is that the coefficients cannot be 0, because if you have a coefficient of 0, that means that molecule is not there. Remember that there's no number written in for your coefficient. The coefficient is 1. Also, your coefficients cannot have decimals, so a number like 1.5 or 2.5 or 3.2 would not be allowed as a coefficient. So if you see something with a decimal, that is not going to be a coefficient. Finally, it should be the smallest number possible, or your number should be simplified. So if you take these numbers here at the bottom, 2, 4, 4, 10, let's say that we set those with the coefficients in front, 2, 4, 4, and 10 going there. That would be incorrect, because you notice for all of those numbers, you can divide them by 2. So the smallest number possible in this case would be 1, 2, 2, 5. So this would be incorrect, the 2, 4, 4, 10, because they're not the smallest numbers. And the correct numbers would be the 1, 2, 2, 5. With that understanding, let's take a look at this equation and see if it's balanced. The first thing we're going to do is we're going to count up the number of atoms on the reactant and product side. So the reactants we have, for the reactants we have carbons only in this first molecule, and there are 5 of them, 5 carbon atoms. There are 12 hydrogen atoms, and again, it's just from this one molecule. And there's only 1 oxygen right now, and so in O2 there are 2 oxygen atoms. So we're just counting up the number of atoms. We do the same thing for the product side. So 1 carbon, that's just from here, and the hydrogen, there's just 2 from the H2O. And then finally for the oxygen, we have 2 from CO2 and 1 from H2O. So 2 plus 1, we add those numbers together to give us a total of 3 oxygen atoms. So as you can see, this is not balanced because the number of hydrogens, carbons, and oxygen are not the same on both sides. So all of them have to be